power. Briefly, and sometimes I have to write this out, x to the 1/2 is the square root of x because there's a 1 there and a 2 there. Sometimes I use this as a reference to like remember like what is this? So this is the 5th root of x to the 4th. And one of the things that you may know here, but we can talk about conceptually, is like if x is less than 0, x to the 4th is positive. And if x is greater than 0, x to the 4th is also positive. So this graph is always positive. And if you have a calculator, you would see that it looks something like this.
Cusp.
Yes. If you don't have a calculator, I don't know how you know that, at your kind of level.
Well, because usually the cusps are like the 2/3 ones. Like
anything to an odd power.
Oh, so wouldn't you know just from?
Yes. So that's like the short. That's how that's how I know it, which is the shortcut, is you recognize that if it's x to an m over n, where n is odd and m is even, you get this.
Okay, that's probably why they put it in
there. So like, but the graph will tell you this. So we got to go back and look at the questions, which is, is it differentiable everywhere, or where is it not differentiable? And basically it's where you said everywhere but this point here. Now here's another thing to do. What is the derivative of this using the power rule? So you bring this number down.
4x to the 5th?
4/5 x, and
then
it's 4/5 minus 1.
Oh, whoa. Okay.
So we're using the x to the n. X to the n becomes n x to the n minus 1. So a lot of students struggle with the fractions here because it's just something you're not doing very often. It's really minus 5/5. So it's minus 1/5. Okay, what is that? So we have to do a little bit of rewriting here. It's 1 over x to the 1/5 power. Is that okay? Is that understandable?
Because you just,
Okay, so this part over here, this is why it leads to the cusp there, and it's because the problem is that at 0 it's undefined. The derivative is undefined because if you put 0 in there, you have a problem if you can't divide by 0. So that's kind of another way to do this problem, to like try to figure it out. But in summary, A it's differentiable for x not equal to 0.
Okay.
It's continuous everywhere. So A is differentiable. B is continuous. And then C says neither. Like where is it? Is it none of these? And there is no place because it's continuous everywhere.
Okay. So if it's differentiable, it has to be continuous, but if it's continuous, it doesn't have to be differentiable, right?
That's right. And that's the example here.
Okay.
So this one, like empty set, these are kind of options for last one, or words that mean like nowhere.
Oh, there was one. Can we, sorry, my cat. There was something like one of the problems I did for the 3.5 homework, Elsa, was like describe the motion of the, oh wait, let me look at the exact question.
Is it in that email you sent me?
I can't remember what page it's on. I think it might be the page before, so I might have to send it to you. But it was, Okay, it was here. So a body is moving in simple harmonic motion. Or no.
Yes.
Yes.
That sounds reasonable.
And then it was like find the body's velocity, speed, and I know how to do that. And then like find it at this time. And then it just says like describe the motion of the body. So like what they wanted was like it oscillates between like 2 points, but I don't know like how to find that.
Do you have the equation that they started with?
Yeah, S equals cosine t minus 3 sine t.
Like this?
Yeah.
Okay. We definitely would need a graph of this, unless you have more calculus, maybe. Were you allowed to graph it with a calculator or not?
I mean, it was in the book, so I assume so, but the other ones were like S equals 2 plus 3 sine t. So would you need like a graph for all of them?
Those are like with one trig function, you can do a little bit more.
Okay, so maybe this would be on the calculator section.
Yeah. Do you want to do it with two trig functions, or do you want to do it like the one you said, like 2 plus 3 sine t or something?
Maybe just start with 2 plus 3 sine t.
Okay. Okay, so you know that a sine function is oscillating from between 0 and 1, and it starts, comes down, does something like that. The three amplifies it. I'm gonna run out of room here, so move this down. Okay, so the 3 amplifies it, so it comes up here to 3, and it goes down to -3. And then the 2 shifts everything up. So it moves it up here, basically. Okay, so our final graph here, and that's the one we really care about. So I'm gonna undo these other ones. Can't do that. See if I can get rid of them here. These are the ones we care about. This is the graph we care about. And you can throw on your calculator if you need to, but then the next thing you can graph is the derivative. And the derivative of this is the derivative of this first part is 0 plus 3 cosine t.
Right. Okay.
And the graph of cosine starts high, goes low. Oops, I missed the point. Starts high, goes low, comes back up. But then this 3 magnifies everything, so it's there. And then this point comes down here, and this point comes there. So it looks more like this. Yeah, something like that. So I got a lot going on here, but it's these windows that we talked about before. Like I could ask you like what's going on from like, I don't know, t equals 0 to pi. And that's this window. Let me use a different color. I don't think I'm doing a good job explaining this. That's this window here. Like what's going on here from here to here. And so the first one, like it went away from the origin, and then it's kind of coming back to it.
Right.
And for the first part, this right here means that it has positive velocity because it's above the x-axis. Notice that coincides with the slope, positive slope. Right here, this has negative slope. So that's why the velocity is negative, why it's below the x-axis.
How did you know that is the period just pi?
Yeah.
And how do you know that?
Just because there's nothing going on inside of this function here. There's nothing that like there's nothing in here to manipulate it.
But like on 16, the one that I did for homework, like the period was 2 pi, but it was S equals cosine t minus 3 sine t.
Sorry, the period is 2 pi. I'm sorry, the period is 2 pi. That's 2 pi and that's pi. Sorry. You sent. I don't feel like this is helping you. Maybe if it is, tell me. But this one's very complicated. It's slightly beyond where where you are. I did remember seeing one in your review. I thought you had a simple harmonic. Yeah, the harmonic motion demo, S of t equals -5 cosine t.
Which problem?
It's on page 3 of the 3.5 day 2.
Oh, on the PowerPoint. Okay.
Yeah, I mean that one looked.
Let me see. Um, Okay. So maybe, so can we do that one? So that
Yes.
for like describing that one, maybe it's probably easier, right?
That would be a little easier to work through, yeah. So let's do that one. So, all right, so we have, let me switch colors here back to the black. So we have y or S of t. The S doesn't matter, but they do use that. S of t equals -5 cosine t. So again, this cosine normally starts high, goes low, and comes back up. Okay. The minus flips it, and then the 5 like expands it. So let me actually just do it in a nice form here and snip in the graph. Okay, so we're gonna just do it for one period. Okay, and hopefully get that in there. Okay, and then the derivative, do you know the derivative of this?
Is it, well, cosine of negative sine, right?
Yes, so the derivative cosine is minus sine, so S prime of t is -5 negative sine of t. And so the two negatives cancel and you get 5 sine t.
So if there's a number in front and you're taking a derivative of it, it just like stays.
Yes, so there's this rule that says C constant f of x, y prime is equal to C f prime of x. That constant
Okay.
always comes with it. Okay, and yeah, I mean, I agree. It's very unclear until you like do this over and over again, then you get what's going on here. So let me snip this in. Hopefully this will be clearer because it's computer generated. Okay. All right. Okay, so first thing to notice is that the blue is the position function. So from yesterday, we know that it starts 5 away from the origin, and then here it comes back to the origin right here. And then it's moving away from the origin, and then it comes back to the origin. You follow that?
Yeah.
Okay. So if you could just look at the blue, which I know it's hard because the green is distracting. If you're just looking at the blue, what is the slope of all the tangent lines along there?
It's going 1, 2.
Just tell me, is it positive or negative? I'm trying to help here. They're all positive, right? So do you see how the green is above the x-axis there?
Yeah.
And it should be because the slope of this curve is positive in here.
Mm-hmm. But what about the other side of the blue?
So let's talk about that. What is the slope going down this way? So I'll draw some tangent lines. It's negative. So do you see how the green is below the x-axis?
Yeah.
So that's the relationship.
So when the blue, well,
the blue is the easiest one because it's physical. It's like I'm away, I get back to my origin.
They have to be the same. They have to be the same slope, basically.
The green tells you the slope of the blue at every point. Maybe I should say that the green is the slope of the blue.
Okay.
And that's essentially what a derivative is.
Okay.
So for example here, like in this from 0 to pi over 2. Okay, like what is happening here? Well, it's heading towards the origin or towards home. Okay, it's heading towards home and it's got a positive velocity because it's above the x-axis.
Okay.
And then in this next window, it's heading away from home, but it still has a positive velocity because it's above the x-axis. So the mistake is to somehow look at the green and try to use its slope. You don't use that. You just look at whether it's above or below the x-axis.
Got it. Okay.
So in this window, it's returning back home and it has a negative velocity. It's almost like if you're in a car, you turned around because you're getting back towards your house. And because you turned around, that's why your velocity is negative.
Okay.
We'll say this is V. And this is S. Okay. And then in this last little window, you're getting further away from your home or the origin, and you're still going in that other direction. That's why the velocity is negative. And like the question would like ask you to describe like what's going on in each of these windows of time.
So there's a velocity graph, which is what this is, right? And then
that's the green. The green is velocity, the blue is position.
Okay. And then there's the acceleration graph too.
I mean, there is, but I mean, we could get into that if you wanted to.
No, I think he said that he's only going to stick with velocity.
Yeah. So
that's more common, right?
Right. So for window number 1, you have to say something about the position and something about the velocity. And then the same thing for 2 and 3 and 4. Like you have to say it's like moving towards the origin at a positive velocity, moving away from the origin at positive velocity. And if that's not clear, we can just fill those in here. So like in window 1, its position is toward the origin, and it has positive velocity because it's above the x-axis.
Okay.
In this middle window, it's heading, the blue is above, and that's, see, that's where it's, you know, a little bit different rules for each. The blue is above, so it's heading away, and the velocity is still positive because it's the green. The green is above the x-axis. The green is above the x-axis.
Okay, so even though the blue is going down, it still is like a positive.
Well, not yet. The blue is going up, but you really only care whether it's above or below the x-axis.
Oh, it's going. I see. It's going away from the origin.
Yes.
Okay.
And so I guess I should be doing that here as well. The reason it's going towards is because the blue is going it's below 2 above, like it's moving, I don't know, that's why I draw the arrow. It's not really, and the reason it's moving away is because the blue is going up 2 above. I don't know how to say that. It's, you know, it's zeroed out here, but then it's moving up above it, the blue.
Okay.
So let's see here. What's another way to do this? Like if I just gave you one of the pictures, I think it would be clear. I think it's because they're overlapping that it's harder. So let me
Okay.
try that. Like this is a really important concept because you're going to do it again in, because like sometimes they call it
Well,
curve sketching and other
so
things.
basically the blue is the normal, right? And then the green is like the
Yeah.
derivative.
Yes. So the SFT, like this is you going, this is towards, and then you're moving away, but then you're coming back towards, and then you're moving away. Because this line right here is your home or your origin.
Okay. That makes sense.
Now let's look at the green and not the blue. I probably should have started out doing this way. The green is the velocity. And so the rules here are, if it's above, let me snip it in. If it's above the x-axis, so in this region right here, this is positive velocity because it's above the x-axis. And here it's negative velocity because it's below the x-axis. And that's what's really hard for students to remember, for you to remember, is that because you'll confuse the two rules, the two, which graphs, but velocity, you're strictly looking at whether it's above or below. That's it.
Okay. Okay.
Okay, where should we move to now?
Let me see what which questions we were supposed to do for the review. It was, so I've already done 53, and then it was 57. I can do that one by myself. 59. Oh, 59 could be good to do.
Okay. Yeah. Oh, yeah. That's right. We're working on all those. Yeah. Okay. This is exactly right. Have you done 60 yet? 60 we should do first.
No.
I'm sorry. 59 is this. I'm sorry. 59 is what we want to do. Okay. Yeah. So there's a whole section in some courses where they really like go kind of crazy on this, and it's kind of a useful thing to do. Did your instructor emphasize whether you would be doing it on the same graph or you could draw a new graph?
He didn't say, but he'll probably give us a new, if it's on a test, it'll probably be a new graph, I'm assuming.
Okay. Sometimes like students like to draw it in the same one. I recommend not doing that. So this is going to be your derivative here. And you're looking for, the first thing you're looking for are the breakpoints. There's two types of breakpoints. Breakpoint A is when the tangent line tangents are 0. Unfortunately, this one doesn't have any. So that's like where you have one of these or one of these.
Okay.
But you don't have that because it's not defined there, and this is weird. So then the second one is you're looking for like points of discontinuity. There's a bunch of those here. So that's
-1.
right. So at -1 it's kind of a break in your graph. And then same thing here at 1. It's a break in your graph.
Yeah.
And these line up. Like that's why I was asking, because I like you actually draw these all the way down. Okay. These like division.
The closed circle under the 1.
Not important.
Anything, right?
Not important.
Okay.
Because yeah, it's just totally irrelevant. Okay.
Okay.
So the easiest window to look at here, we're gonna label these 1, 2, and 3, is we're actually gonna start with 2 first. So 2 has a slope. What's the slope of this line? You can actually calculate the slope of this line. It's rise over run. Now, maybe you're like, it's not defined there. Well, you just assume it is. So you're going up 1, 2, right, 1, 2. So it has a slope of 1.
Okay.
So you have the graph here. And this, so this, I don't know, I guess right on here. This has a slope of 1. And that corresponds to this line right there. Because the derivative literally tells you the slope of the graph.
Okay.
Okay. All right, so now how about in window 3? What's the slope of this line? Well, it's down 2,
Negative.
right 2. So it has a slope of -1. So we got that's our breakpoint there. So it's got a slope of -1. So it's this right here. It's this line, this horizontal line.
So you just draw like horizontal lines basically.
When it's a straight line, because that's why 1 is a little bit harder, because
Oh, I see.
it's
That's like that shape is like the same as like a tangent curve or whatever it's
kind
called.
of like, there's actually I did misspeak here. There is a horizontal tangent right there, and there's one there. So what that tells you is that there's a 0 there and a 0 there.
Oh, okay.
Okay. And is the slope of this positive or negative? I'm drawing little tangent lines to help.
Positive.
Positive. So that means it has to be above the x-axis in this region.
Okay.
So what is the only way you can connect 2 points like this? If it's got to be above, it's going to look something like that.
Or can you do like an absolute value like the other one?
Because it's continuous, this has to also be smooth.
Oh, okay. So a parabola. I see.
Okay, so this is not the best example to do to start out with. Have you done this before? These curve sketching things?
I honestly don't think we have, so I'm
Okay.
kind of confused why he assigned them in the review problem.
Yeah, I don't. It's a little mishmash, and I'm worried that like instructors trying to like simplify this a little too much. Okay, where is the horizontal tangent equal to 0 here? Like, where are all the tangent lines? See how all you can draw all these different tangent lines, but there's one right there where it's 0, right there. Okay. So what if I look at window 1 and then window 2? Tell me about the slope of this on the right. Is it positive or negative?
Positive.
Because it's above the x-axis over here. This is y. This is y prime. Okay. And
so
what about this over here? What are the slopes of this?
Positive.
They're going down though, down to the right. So they're negative.
Oh yeah. But
You got to look at the tangent lines. They're negative. So that's down here. Okay.
but
Now,
how do you know that the tangent, like how do you know that the tangent lines are going down?
well, you just draw one. You just draw one that's tangent to the graph.
Right, but isn't that like the parabola arrows are like going up?
Right, but they always kind of point down and to the right.
Oh, okay.
Okay. You'll get it here. And this is the graph of y equals x squared. What is the derivative of x squared?
2x.
Does this look like 2x kind of?
Yeah.
Yeah. Okay, let's do one more. At least one more. And this is kind of the better way to learn curve sketching. Maybe you do it again. So let's look at y equals x cubed. Okay, so here's what x cubed looks like that. Okay, what's going on right there at the origin? What's the horizontal tangents there? What do they look like? 0. So
Well,
if I come,
it's gonna be, the derivative is gonna be 3x squared, so it's gonna be like a parabola.
but let's try to avoid knowing that for the moment here.
Right, but like to check your work, that's
yes,
like,
yes,
okay.
but I'll eventually give you some where we don't have this. What's the slope of the tangent lines here? Are they positive or negative?
Positive.
So that's up here, right?
Yes.
And then over here, they're also positive.
Yes.
So you get back to that. Now, why does it have this shape? Well, the tangent lines go from being really, really positive to a lot less positive.
Mm-hmm.
And that's why it does this, but it's still positive. And like you said, it's y prime equals x, 3x squared.
Okay.
So another good one to do here is like where I give you a graph where you have something that comes down, goes up, comes down, goes up, something like that. This is your sort of your exam question. So the first thing you identify are the horizontal tangents. And you map these down. 0, 0, 0, because the tangent line is literally 0 there.
Okay.
And then we look at each window. So doesn't matter whether it's above or below the x-axis. Are the tangent lines here, are they positive or negative and sloped?
They're negative.
Negative, which means it has to be down here. This has to be down here. How about in this window? How are the tangent lines going here?
Positive.
Positive. So that means it's up here. And see, these lines got to connect. So those connect.
Negative.
Negative.
And then positive.
Now this is like some sort of x to the fourth. So does this look like some sort of x cubed here?
Yeah, kind
It
of.
does. Kind of does. Yeah. Okay, let's jump back to 50, 60. 60 will make a little more sense now that we've done this one. I hope.
Okay, so first one is so none of them are going to be straight lines.
No, that's a mistake. That's kind of to think like most of these end up being curves when you actually do them for real.
So the first one had straight like horizontal lines, right?
Yes, but that was wasn't like usually you do them with smooth ones. Even this is weird because it's got these asymptotes in it, but
so the first one is positive slope.
yeah, so this one over here has positive slope, right?
Yeah.
But now because and do you see it's kind of 0 right there? So we put a 0 right there.
Yeah.
Now, are the slopes getting more positive or less positive?
More positive.
More positive. So that means we go up like that.
Okay.
So it actually looks the same, which can happen. There's a few examples of that.
And then it's also positive.
Yep, positive everywhere. But notice they go from being really, really positive to much closer to 0. That's what that looks like.
But doesn't
sorry?
Does that have a negative slope?
Nope. See how they're positive?
No, yeah, but the one you just drew.
These are all positive slope. Doesn't matter that they're below the x-axis. You
No,
got
I know, but the one below that,
this one here.
Yeah, doesn't that have a negative slope?
It does, but remember we're looking at the slope of this top one.
Right, so it's positive. So shouldn't the one that you draw also have a positive slope?
No, it has to be above the x-axis. So that was the whole thing up here in the green. Let me try to, if it has a positive velocity or positive slope if it's above the x-axis.
Right. Okay.
Like this thing, even though, and you're making this classic mistake. So it's a good thing we're doing it here. Like it doesn't matter that this is below the x-axis. It matters that it's going up and to the right.
Okay.
And that's why it has positive slope. So we come down here to your question, like you're like, hey, but it's negative. Like doesn't matter. It's up and to the right is the slope of this curve.
So then the one on the right side will just be the connector, like the parabola.
Exactly. And that's why I do these zeros first. I haven't really emphasized that because they have to connect in. Like if you come down like this, you actually know you're going to immediately come back up like that.
How did you know that is the 0, but the 0 is not on the origin. It's like below the origin.
That doesn't matter. It's wherever the horizontal asymptote is, or the horizontal tangent is 0. See how right there is the m is equal to 0.
Oh, yeah.
And that's this point right here on the right maps down to here because it's got a horizontal slope of 0.
because it's just straight. Okay. So then that one has a positive slope.
Right, so it looks like that.
Okay.
Because it's got to be above. You're going to want to do this on your own and somehow come up with like your own ways of like rationalizing this to yourself, because it is hard. It's very hard the first time.
Okay, that makes a lot more sense now though. So then maybe one.
We didn't do 68. We should definitely do something like that at some point.
68 and 60. Which one did we just do? We did 60. What was 60?
Yeah.
Oh, that's just like, okay. We don't need to do that. Yeah, 67 and 60. Well, 67 is the one I'm assigned, but we can do either. And I think we already did 81, right?
Yes.
And then 82. Okay. So we can do 68 or 67.
I mean, both would be good to do 60s. Let me do 68 because you'll have 67 answers to look at. Is that agreeable?
Yeah, sure.
Okay. In case we run out of, I mean, I don't think it'll take that long, but there's so much going on. Okay. Let me actually snip this in differently, because what you really want is the table, and then we want the question. So question A. Question A. So they want you to take the derivative of this 3f of x minus g of x. And we'll get to the table. So it's 3f prime of x minus g prime of x. So we're just taking a straight derivative. The constant comes down with it.
Okay.
Okay, so now we need those values. Now, so see, it says x equals -1, so you have to put those in here. 3f prime of -1 minus g prime of -1.
Okay. And then do you like multiply the.
So f prime, let's go get the values. F prime of -1 is this number right here.
Oh yeah. Okay, I remember doing this now.
And it's
So-
pretty easy once you get the right thing. You just go and look
Yes,
it up.
we did a worksheet with this. Okay. So so yeah, okay. So then that's 6, 5, 5.
Yes, 6 minus 1 is 5. Yep. Okay. So now let's do B. B is, let me snip it in. Actually, I just write it out. It's a little bit. So f of x, g of x, and they want it at x equals 0. So this is the product rule.
Okay.
Remember that from yesterday?
Yeah.
So it's f of x times g prime of x plus f prime of x times g of x.
So do you use the 0 or do you use the -1 for f of x?
Well, so that's where this next step is. You take this 0 value and you put it in everywhere. So it's f of 0, g prime of 0 plus f prime of 0.
Oh, I see. It tells you which one to use. Okay.
Yeah, it has to. Like, it's not a like give choice. You just
All right. So then it's f of 0. So it's -1.
So f of 0 is this one right here. Yeah, so it's -1. And I would definitely double check these, g prime of 0.
3. Oh, yeah.
4.
And then
There.
-2. Or no.
G prime, you're using this one up here.
Yeah, but for f prime of
Oh,
zero?
f prime of 0 is -2. And then g of 0 is -3. So you got -4 plus 6, 2. Instructors love these questions. They're
Wait,
easy.
I'm kind of confused. So for f prime of, or like for g prime of 0, how do you know which one to use?
Here's the x values. And so g prime of 0
Oh, I
means I'm
see.
going to this
It's all
column.
it's the bottom row,
Yes,
right?
yes, yes.
Okay. Okay. So then 2.
All right, so then next one here, C is, oh, it's the same thing, but at -1. So we'll just grab a few value. See, actually, let me re-snip in this picture here. So C, part C is the same thing, but it's at x equals -1. Let me grab that right here.
Okay, so you just do negative or 0 times 1 plus -1 times 2, right?
So at -1, yeah. So it's 0 times 1 plus -1 times 2. Yes.
So 0 plus, or 0 minus 2. So it's -2.
Yes. Part D is quotient rule. So we got to go through that. Let me grab part D. The main thing with this one, as I mentioned yesterday, is the order, is just getting it right. It's the bottom times the derivative of the top minus the top times the derivative of the bottom. I actually prefer the words to the formula because it's
Bottom squared, right?
Bottom squared, yeah. And then you're doing it at 0, so it's okay. I got to grab g of 0. I think you made a good. You're only using values in the bottom row, so that could help. Help you if you cross one out or something. That could.
So it's g. Okay, so it's g of x. So -3.
Okay.
Oh, you were -2 and then minus -1 times 4.
Yes.
And then
So,
it's -3 squared.
yeah, you end up using all the numbers, but you have to make sure you get the right order, or it
Right.
gets a little weird.
So then that's 6 plus 4. So 10 over 9.
Yep.
Okay.
And then part E is going to be a repeat, but it's at the other x value. So let me get that snipped in here. Where did it go? Sorry, I got clicking around here. There it is.
Then
So
we have -1 times 2 minus 1 times 0, right?
So yeah, bottom -1 times 2 minus 0 times 1 over
-1 squared.
yeah. No, the bottom is, well, that was a mistake. I apologize. The bottom is the original value. Oh, we did. Okay, we are okay. We're okay. I'm sorry. I'm getting issues here. Okay. Yeah, so it's -2 over 1. So just -2. F is the most difficult one. So the bottom has this like +2. So so this is your bottom that I've circled. So it's g of x plus 2. That's your bottom times the derivative of the top minus the top times the derivative of the bottom. So the derivative of the bottom, you have to maybe go over here to the side and say, okay, what's the derivative of this? So it's g prime of x plus, what is the derivative of a constant?
Itself?
0.
Oh.
0, yeah. And that's why you gotta, because it's very easy to be like, oh, what is it? So it's g prime
Wait,
of
and
x.
then the derivative of x is 1.
is 1.
Okay.
And then the bottom squared is g of x plus 2 squared, like that.
So then it's, oh wow, okay, so it's in x equals 0, so -3 plus 2 times -2 minus -1 times -3 over -3 plus 2 squared. Is that right?
I didn't catch all those, but it's, I mean, it sounded like you're in the right direction.
Okay.
It's, yeah, it's a lot here, but it's, yeah, so it's g of 0, which is,
And then you just evaluate that. Okay. And that's the same for, it's just the same process for 67, right?
yes. Definitely want to go through it, once on your own, if you can.
Yeah, that one I have to do anyway, so I will do that and probably tonight.
Okay. We got a session tomorrow, I think, the song.
Yes.
So try to come ready with, any last minute questions for that. That way, get them answered in time.
Okay, I think I want to go through, I think it was like in 3.3 or something, we did like a particle motion, something. It wasn't like a harmonic motion, it was like something else, like tracing it. So
Okay,
go
you
over
can do that.
next time.
You can absolutely do that. And all right, I think
Okay,
that's it.
perfect.
So thank you so much for scheduling, and I'll send you the notes and the screen recording out a little later tonight. And I'll see you tomorrow.
Okay, thank you. Bye.
Welcome. Bye now.